Welcome back to a new video. In today's video, we will be talking about DNS in details. So basically, you will learn how domain name system works. If you know how domain name system works, then this video is not for you. This video is for all of the people who have been wondering how the DNS works, although they are in more senior positions, like some of them could be working in IT, could be working in system administration, network administration, or even pen testers. Sometimes the DNS part is still ambiguous and needs some explanation. So in this video, we will uncover all of that with DNS in detail room from TryHackMe. So I'm sure all of you know how to read through the tasks, but I would like to explain the idea behind the DNS in a separate board, and then we will answer the questions after we make sure you grasp the idea of how the DNS works, including all of its parts, the components, and all other related details. So let's jump right to the board. So the first thing in the DNS, how the DNS works. What is DNS? So basically, DNS stands for Domain Name System. In a nutshell, how the DNS works. So normally, we would request in our browser sites like Google, Facebook. You would also go to offensive security site, OSCP sites, whatever. You would ask for snapshot website. So DNS, what does DNS do actually? It is understanding your request. So if you're asking for Google, if you're requesting Facebook in your browser, if you're requesting Snapchat, it understands your request and then it gives you the exact address of the domain name. So here, let's do this. One arrow like that. So DNS takes the name you enter into the browser and converts the name into an actual IP address. Right? So basically, what is that IP address? The IP address here is the IP address of the server that is hosting snapshot website. So basically here you have say a server, right? And this server, it has snapshot website. The server has an IP of, let's say, 105 25 10 5. This is the IP address of the server hosting snapshot website, right? Now, the DNS actually sits in the middle here. So in the middle between the name or the site you're requesting and the actual destination where the DNS sits, it translates the request in the browser from a name into an actual IP address. The IP is the IP of the server hosting the website of Snapshot. Simply, that's how DNS works, right? Now, let's talk about DNS components. So in DNS, you may have heard about something called TLD, right? And also there is something called gTLD, and also we have ccTLD. So, for heaven's sake, what is TLD? TLD is top level domain. Okay, an example of TLD is like .com is an example of top level domain. You have .org, .edu, and .government. So all of these guys are top level domains. Okay. And also you have other top level domains like what could be other top level domains? .net is also a top level domain. Now let's talk about the gTLD. So gTLD stands for generic top level domain. All right. So generic top level domain are all other extensions or all extensions other than these guys. For example, .me, .online, dot club, dot website, dot biz. All of these are generic top-level domains. And then you have the ccTLD. CC stands for country, all right, country code top-level domain. An example of that would be .de for Germany, .fr for France. You get the idea. .uk for the UK, of course, and the rest of that. So this is the basic hierarchy of the domain name system. Now we have something else. Let's talk about subdomains, right? So subdomains, or let's keep the page as is. So subdomains, let's write it here, subdomains. So a domain would consist of something like, let's say, TryHackMe.com, right? Now we agreed that, no dispute, right, that .com is the TLD. All right. Now TryHackMe is the domain. How about if there is something like blog here? Now blog is the subdomain, etc. This is the components, right? Okay, now this is simply the structure of the domain name system. TLD, gTLD, ccTLD, and the basic components, or how you map them to a simple domain name like tryhackme.com or blog.tryhackme.com. Okay, next thing about DNS is DNS records. So as a pen tester or as a system admin, you may be dealing a lot with something called DNS records. What are the DNS records? So the first thing, or the first component of DNS record is the A record. A record is a record that maps an IP or resolves to an IP address. So basically, normally a record holds an IP address, IPv4. Then you have the 4 A's. This is for IPv6. And also you have CNAME. So CNAME resolves to another domain name. Normally in the CNAME goes something like www, right? So if you have a domain such as tryhackme.com, it goes like this. So you would add www to tell the DNS that when someone types in www.tryhackme.com, the records will go to tryhackme.com, or the browser will request tryhackme.com. Now we have also the MX. MX for emails, if you have an email server. And lastly, you have the text record. Text record mostly used for verification. Here you have text field. If you want to verify your site for the Google Search Console, or if you want to add SPF records, anything in text goes here. Anything for emails goes in MX. Anything goes, IP addresses goes in A and 4th A, and lastly for names, we have the CNAME. Now, these are the DNS records. Now let's talk about what happens when you request a web page in your browser. So normally you have a domain name such as tryhackme.com. Okay, the first thing you would type in this into the browser, right? So you would go to the browser, Firefox, Chrome, you would type in the request in the browser. And then what's gonna happen, your machine will ask the IP address of TryHackMe in your local cache. take the local DNS cache in your computer as a table, like that. Okay, it's a table where you will have, for every domain name, you have its IP address. So your computer will ask the local cache here if tryhackme.com is actually in the table. If it is, it's going to retrieve the IP address and give you the page or give you the destination of tryhackme.com, and you will be able to access the web page. If it is not, so here, if it is yes, wait, let me do some, oh my god, no. Okay, so I just paused the video and resume it back. I don't want to waste your time, so I have drawn everything here, and we reached the point where we were talking about the local DNS cache in your computer. So if TryHackMe is within the local cache in the table, the browser, or you'll be able to access the computer, will immediately retrieve the IP address of tryhackme.com from the table and give you the, or relay the so I have paused the video just to draw everything from scratch, and now where were we, by the way? So here, so basically we were talking about the local DNS cache, where the local DNS cache is actually a table of domains and their IP addresses. So if your computer has or if TryHackMe is actually still registered in the table, the computer will retrieve the IP address and it will relay your request to the destination itself, and you will be able to access the website from your browser. Now, if there is no records for the domain name you are requesting, the request goes to something called the DNS, sorry, the recursive DNS server. Now, what is the recursive DNS server? By the way, the recursive DNS server is the kind of server that is provided by your ISP, the Internet Service Provider. So when you have an internet subscription, your ISP provides you with a recursive DNS server. All of this, by the way, happens in the background, all right? So when you subscribe to the internet and the technical guy installs the router in your office or in your home, every request goes to the router, right? And the router has the recursive DNS address for your ISP, which will give you the IP address of tryhackme.com. So if you don't have the records in your computer, you will ask your ISP. Now, let's say that your ISP doesn't have the IP address of tryhackme.com. What's going to happen now? Let's draw a loop here, like that. The request goes to something called the root DNS servers. Normally, everything is recorded in the root DNS servers. The root DNS servers will first look if the domain name you're asking to access, what kind of TLD it has. So it will look here. First, it will see that you have .com, which is a top-level domain name. What's going to happen now, the root DNS servers will ask what? Will ask the top-level domain name servers about the address of tryhackme.com. And this will directly lead to the authoritative DNS server. Now, this is the final destination, by the way, here. The authoritative DNS server is the DNS server that contains, or actually they are the name servers responsible for storing the name servers. So basically, an example of authoritative DNS server could be Cloudflare Cloudflare, GoDaddy, and also Google Cloud. These are examples of authoritative DNS servers. They are the last destination to ask. So let's go over that again one more time. You request TryHackMe in your browser. Now, your computer will look if TryHackMe is actually registered in the local DNS cache. If it is registered, your browser will be able to access the IP directly. If it is not registered, your computer will relay the request to something called the Recursive DNS server, where it will retrieve or will try to retrieve the address or the IP address of tryhackme.com. We said that Recursive DNS server is the DNS server provided by your ISP and usually stored in your router settings. Now, let's say that even your ISP doesn't have records of the IP address associated with tryhackme.com. It will ask the root DNS servers. Now, root DNS servers are the backbone of the internet. Their job is to redirect you to the correct top-level domain server. Since the top-level domain here is .com, it will ask the top-level, or it will ask a top-level domain server about that. And this in turn will lead to something called the authoritative DNS servers. It is the place where your DNS records are maintained, such as Cloudflare, GoDaddy, Google Cloud. These are places where you would store your DNS records, and these places would be asked about the IP address of your domain name if all of the previous methods failed to retrieve that IP address. Now, after we have explained all of the theory behind the DNS, let's now go back to the room and answer some questions. Let's get you some answers. So this is the room. First question, what DNS stand for? Domain Name System. No one would have troubles answering that question, right? Next one, what is the maximum length of a subdomain? 63? And you will find the answer here. Which of the following characters cannot be used in a subdomain? So it's asking which of these characters cannot be used in a subdomain. Can you use 3, or can you use B, can you use underscore, or can you use hyphen? The answer to that is the underscore. You cannot use that in a subdomain. What is the maximum length of a domain name? 63, the same. No? Let me check. Personally, I don't know the answer for that. Let me check for the answer here. Two five three. Okay. What type of TLD is .co.uk? So it is ccTLD. Why? Because it contains the country code. Now, record types. What type of record would be used to advise where to send email? We said that MX are used for emails. What type of record handles IPv6 addresses? 4As. What field specifies how long a DNS record should be cached for? Well, we didn't talk about this. It is the time to live. The time to live is a value in seconds that specifies how much or how many seconds should the name of should the records for a specific domain name be stored in your local cache. What type of DNS server is usually provided by your ISP? It is the recursive. What type of server holds all the records for a domain? Authoritative. Okay, last one is practical. Using the website on the right, we can build requests to make DNS queries and view the results. The website will also show you the command you would need to run on your own computer if you wish to make the request yourself. Now let's talk about the practical part of that. So there is a tool you can use to understand more about how DNS works. It's called DNS Lookup. It would ask for the DNS records of a specific site. If you hit enter now, run, you see it's giving you the address, the IP address of the server. But if you would like to find out the records stored in the DNS server, such as the A, 4As, MX, whatever, we would specifically address this in the command. For example, if we would like to ask about A records, you see the command would be --type equal A. Here we would be asking about the A records for the website.thm. And as you can see, the address is 410s. If you would like to ask about the CNAME, we would type --type equal CNAME. So there is no CNAME here. All right. MX, this is the MX record, which means that the site is using Google Mails for creating and communicating with email addresses. Last one, text. You would type --type equal text. This is the flag, by the way. So that's one tool you can use to understand more what type of records stored in a specific website. In the pen testing context, during your enumeration, you would use NSLOOKUP to find out the entries in the DNS server of your target to help build a better picture or a better map about the resources of the target. Okay, what's the CNAME of the shop.website.com? So if you type here shop and type CNAME, the CNAME is non-authoritative answer shop.website.thm, canonical name shops.myshopify.com. So can we copy that? I'm wondering. Yes. What is the value of the text record of the website.thm? This is the text record value. What is the numerical priority value for the MX record? Let's talk about that. So if we type MX here, this is the priority. You can find it right before the address. And lastly, what is the IP address of the A record of the website www.thm? So we type here www.a, and this is the IP address. So we finished the room, and I hope this was kinda helpful. Yeah, and we'll see you in the next video.